Thank you, Martin. Is this on? Yeah. Thank you, Martin, and good morning, everyone. So I watched a video clip recently of Tesla factory, and the production manager was walking a group of people through the factory, and the passion on his face was so obvious. His eyes were bright, and he was smiling, and he obviously was so excited talking about the technology that they had in place. And at the end of the walkthrough, he was asked, or rather he was told, that you guys build great cars. And he said, and if I can please apologize up front to Rolf, he said, "We do not build cars, we are building the future." And I couldn't help noticing, as I looked at the different robots, all the robots were made in Germany as well. What's the point? I'm going to share with you some technologies that we are developing in CSIR. I've been at the CSIR for a long time. In fact, a long, long time. And the technologies and developments I'm going to share with you today are led by guys who I know, and women, ladies who I know very well. I've worked with them for many years. And I can say with honesty that although we are building and developing things, we are not just building products and devices, we are building the future. That is the mindset of the group of people working in this field of endeavor. So we are building the future. I'm going to show a couple of slides that I know are uncomfortable to show. I show them because the work we do is framed by the CSIR Advanced Manufacturing Strategy. All strategies take stock of the external environment. You probably have seen these slides previously, but I don't have to remind us that our manufacturing sector is in dire straits, the South African manufacturing sector. We are in a stage of what's called premature industrialization, the top graph. And the manufacturing value add has also not kept up with the value add of other sectors. This drives our work in CSIR, and our vision, our massive transformative purpose, that challenge which gets us up in the morning and brings us to work, is to catalyze reindustrialization in South Africa. Obviously not working on our own, but working with partners, working with universities, industry, funding agencies. We take on this role and responsibility through technological innovation to catalyze reindustrialization. It's well known that advanced manufacturing is the only way to do this. We cannot go back to Industry 2.0. We've got to move beyond Industry 3.0. So this is the compelling situation and our vision that really is behind the work that I'm going to share with you. So the fourth industrial revolution, or next industrial revolution, has been covered in a number of talks already. I'm just going to show you one slide. There are different views of this, but these essentially are the technologies underpinning this revolution: autonomous robots, simulation, system integration, industrial IoT. Cybersecurity is a big challenge still. The cloud computing, additive manufacturing, augmented reality, big data, and analytics. This is from the Boston Consulting Group. PwC recently did a survey of over 2,000 companies in 26 countries around the world to determine the current investment in these kinds of technologies. And these are the numbers they come up with. You might not be able to read it, but essentially, the companies, the 2,000 they surveyed, and these are all industry leaders. These are influential companies who spend lots of money. The investment per annum, or expected investment per annum, till the year 2020 is about $900 billion. Their expected return on the investment is big improvements in revenue and massive cost reductions. So this seems to be a good area of investment. Not that I'm a financial advisor, but I kind of would buy this return, wouldn't you? 33% of the companies that they interviewed say that they've already achieved advanced levels of digitization. But 72% say that in 4 years' time they will have achieved advanced levels of digitization. So as has been explained previously, the fourth industrial revolution is here. It is happening, and it's happening very quickly. Globally, 35% of companies expect revenue gains of over 20% over the next 5 years, and 43% expect to lower costs by more than 20% over the next 5 years. Okay, so this is the global context that our South African manufacturing industry operates in. And we simply have no choice but to take part in this and to prepare ourselves properly. So this drives and guides the work in CSIR in this field. I'm going to summarize, that's really all I can do, summarize some of the work we do in these fields of technology. 2 disclaimers, I'm not a specialist in any of them, so I'm going to talk at a very high level, sort of in layman's terms, and also the examples I give are very illustrative. So if any of my colleagues are here and I don't cover your pet project, I'm really sorry. Okay, a couple of disclaimers up front, but let me start with advanced robotics. You probably know this, but current automation in manufacturing is expensive. The robots are rigid. Many of them are still unsafe in that they need to be caged, separated from human workers. They're bulky. But the new generation of robotics are lightweight and assistive, much more affordable, human-centered, flexible, etc. And this has been enabled by, apart from some of the technologies we saw earlier on, but also by advancements in new materials. Okay, so the whole field of robotics is changing very rapidly. And the cobot market, this is the collaborative assistive robotic market, according to Barclays Capital, could grow from just what it currently is, just over $100 million, to $3 billion in the next 4 years. So this is a massive market. Two other developments really are around reconfigurable manufacturing machines or systems that are very agile. They can, a single robot can produce a number of products. It enables mass customization, lowers capex costs, and these robots are also part of interconnected and integrated systems. They communicate with each other as well as human factory workers. Then assistive robotics. These are robots that share a work area. They interact directly with humans. They perceive the environment. They respond to the environment. They communicate with people in a number of ways, including verbally. They're able to navigate autonomously, and they can make decisions independently. So this is the new world, and it's already being implemented in many manufacturing companies, but increasingly so as it's enabled by the other next industrial revolution technologies. So just to summarize this, factories of the future will be adaptable, reconfigurable, and allow humans and robots to work alongside each other. Now these developments guide CSIR's work in robotics. I'm going to share with you some of the work we do. And in this field, we really work across the research and innovation cycle. We do early stage research as well as we've developed very practical applications and systems as well. I'm going to give 2 examples of early stage research. Firstly, multi-robot systems. These are systems of robots that work together. They need to navigate around each other, around the factory floor, often in a very dynamic environment. They need to optimize themselves, in a sense, really resource allocation optimization strategies. So we're doing early stage research in this, largely mathematics-based at the moment, but really putting out some good scientific research. And then mobile manipulation. These are single robots that are mobile. We're developing the science behind this that enables adaptive, reconfigurable grasping. That looks like a swan, doesn't it? And really what robots can do nowadays that we are researching is that they can be programmed by physically moving the robot to pick up something and move it, and then the robot essentially programs itself. It remembers that movement, and it learns as well. It improves itself So, the old way of programming robots where you need a degree in advanced programming is changing very quickly. Really, any factory worker can program the sort of new age of robots. Then in terms of specific applications, this goes back a few years, but it demonstrates what we can do practically. A company that was involved in injection molding, every now and again the mold would pick up a defect, needed to be repaired. Previously, that company would have to travel to CSIR, our laser center, to have that mold repaired. You can imagine the time and the cost involved in that. So what we developed was a mobile solution, really truck-based robotic system that could go to the factory. And what it does is that it takes the original CAD drawing, you put that together with a CD scan of the defect. The robot then figures out exactly where the repair is and repairs it on a very small scale, sort of millimeter scale. Okay, so that just demonstrates some of the work that we can do. And then secondly, although not specifically linked to manufacturing, we've developed an autonomous rail vehicle. It's called SID. I can never remember what SID stands for. Something inspection device. That one, but SID. So what SID does is that it drives 2 kilometers ahead of the train, and it looks for obstacles or anything obviously wrong with the railway line, and obviously communicates back. And we're looking at different drivetrains, batteries and fuel cell technology being amongst the most recent. So field testing is in progress with SID. In fact, you can see SID outside somewhere if you want to introduce yourself to him. Okay, then additive manufacturing. This is a field CSIR is very involved in. I might be biased, but I think that we have world-leading research going on in this area. There is an advanced manufacturing collaborative partnership in place that we are very involved in with universities and industry. And our work here is guided by the South African Additive Manufacturing Strategy, which has been published earlier this year. It has 4 priority areas: qualified additive manufacturing parts, focused on medical and aerospace applications, but also applying additive manufacturing in traditional manufacturing sectors to improve competitiveness and provide all the other benefits that come with additive manufacturing. We're also developing, the strategy also focuses on developing new materials and technologies with a focus on beneficiation, just looking at the raw materials that we have in South Africa and adding value to them. And then SMME development support and 2 cross-cutting initiatives in capacity development, education and awareness. So our focus in this national strategy is around process development and application development. Process developments are focused on powder-blown additive manufacturing, aerospace applications, looking at specific metals and metal alloys, and then high-speed selective laser melting, and then finally the application development at the moment is in the power generation industry, working with Eskom as a major client. AeroSwift, I'm sure is not new to you. It is the flagship project in additive manufacturing. It is a national flagship project. It's a collaboration between AeroSud and us to design and construct a large area powder bed AM system for metallic components. It operates at a high speed, it's very versatile, and it can produce large metal parts an order of magnitude faster than the best commercial systems available at the moment. Process controls are built in there, of course, and some of the materials that it can work with are listed there. Then micromanufacturing, although not specifically mentioned in the usual list of next industrial revolution technologies, micromanufacturing is an emerging manufacturing technology. We believe it has lots of potential, especially for generating new industrial activity, not necessarily hundreds of thousands of jobs, but there's potential to set up a very high value, low volume, high value new firms, SMMEs, that can be very profitable and export. So not only are we involved in helping the existing manufacturing sector become competitive, but we are looking for opportunities to create new manufacturing activity. So I've got a few slides I'll go through very quickly. We have a clean room for soft lithography. We can manufacture silicon wafers with feature sizes of 20 microns and above, and thickness down to half a micron. The examples there, the wafers on the left produce the microfluidic components on the right. And microfluidics is a big focus area in our micromanufacturing platform. So microfluidics uses very small quantities of different reagents. Chemical reactions can be controlled very precisely, and so it allows these reactions to be very controlled very precisely. Two applications that I'd like to share with you that we have developed. The first really is the basis of our Cellnostics project you might have heard about. It's a blood counting device. And then the second one at the bottom there is the microencapsulation. We have printed functionality capabilities, 4 types of printing: wax printing, bioprinting, inkjet metals printing, and screen printing. And those are some of the applications we're working on at the moment. Then I think it's fair to say that we have put our toe in the water in industrial IoT. This is clearly one of the big enabling technologies for the next industrial revolution. I just want to share with you some of the work we are doing here. Internet of Things, in case you don't know, this is really the internetworking of everything. And it enables whatever is can be fitted with a sensor to collect and exchange data. And it's estimated that by 2020, there will be over 26 billion connected devices. Our focus at the moment is on smart warehousing to enable optimal routing and placement and movement of goods in simulated warehouses. IoT Augmented Awareness. At the moment, what we have developed is a helmet that allows gunshot detection in a crowd. It's fitted with 6 cameras and 6 microphones, so it allows triangulation to actually detect where gunshots come from. From this platform, we are thinking of, and provided we can partner with someone and establish that this is a real need, I guess, but to have these helmets in a factory as well, to be able to continually monitor certain process parameters. There's also a focus on energy saving. Then my personal favorite is augmented reality. Augmented reality provides massive opportunities for industry. It's a technology which enriches the real world with digital information and media such as 3D models and videos. These are the main applications at the moment. It facilitates complex assembly. At the bottom left there, you have a factory worker fitting a door panel to a car. And she can actually see where she needs to fit this panel, and she will be corrected if she doesn't fit it properly. Maintenance is a big application as well. The picture in the middle there is, the factory operator is guided to set, pressure and temperature correctly. Quality assurance, expert support. You can imagine if a company has very specialized equipment from overseas, and instead of having to fly the expert out, he can guide the operator through augmented reality. He can point out exactly what needs to be fixed and what needs to be done. Training, this provides massive opportunity for training. I think we have heard in yesterday and earlier today as well, some of the concerns about the impact of the NIR, FIR on jobs. And there is a huge skills gap in this country. We are going to require much higher level of skills to be successful in the third and fourth industrial revolution. And augmented reality, we believe, provides massive opportunities for us. To fast-track training, you can take training to the factory floor in the operating environment that a person works in. So we're taking this very seriously as an organization. And the best I could have showed you was a similar photo to the one at the bottom right. But we are doing some work at CSIR. So that's the only slide I have for that. But as engineering.com recently stated in a recent publication, we've only begun to scratch the surface of what augmented reality can do for manufacturing. And we firmly believe that. Product lifecycle management has been discussed enough. I'll skim through that. Just to stress that this is the enabler, if there is one, of Industry 4.0, of the next industrial revolution. Okay, this is the platform that is going to enable it. And just remind you that CSIR is hosting a product lifecycle management technology center. The initial focus is on the 4 sectors mentioned there: medical devices, mining, transport, safety, and security. And I don't have to remind you or point out to you the benefits that can be established through PLM. Benefits in reducing time to market, product development costs, product costs, cost of quality, and change management costs. There are massive improvements to be had. Then, apart from the individual technologies that I've mentioned, disruptive innovations increasingly happen at the convergence of technologies. So I just want to share with you an example of a CSR example. So apart from having specialists with deep knowledge of these specific technologies, organizations to be successful in innovation also need the integrators, the generalists. And increasingly, this is where the innovations are going to happen. This is an old slide from a European document, but an example here is the smartphone. The smartphone innovation was possible because it brought together advanced materials, microelectronics, nanotechnologies, and photonics. Then a CSR example. Someone who presented yesterday actually stole the slide from me. I won't mention who he is. No, I'm quite happy when slides are shared, important slides. This is a product that CSR developed. Coracam, this is a very successful product. The company's been spun out. It is producing or earning millions of dollars of revenue, exporting overseas. Very successful company. What enabled this innovation was bringing together these technologies, and I'm sure others, but mainly additive manufacturing, microelectronics, photonics, digital, ergonomic studies, advanced materials, and advanced sensors. And then there are plans also to continually improve and get to the next versions of this product using building an Internet of Things, continually making it smaller, miniaturization, putting augmented reality in there, etc. Then in terms of how we perform innovation, or our research, I've explained why we do it, what we do, and this is really the how we do it. The closed innovation paradigm is really driven by that not invented yet syndrome. You might have heard of that, where companies are not interested in ideas unless the ideas come from their own staff. Now, a lot of research has been done traditionally like this, but increasingly organizations like CSIR are committed to an open innovation model, where we accept ideas from everywhere outside of our organization. We co-develop ideas, we do projects together, and as we do that, we will see new opportunities. New products can come out of the collaborations, new markets can be created. So in this field of research and emerging technologies for manufacturing, this is the model that we adopt. Right? So we are open for business. And then finally, whenever there is a new idea, industry naturally and understandably wants the risk to be reduced as much as possible. As a research organization, we need to take ideas out of the lab. We can prove that an idea or technology or device works perfectly well in a laboratory, but that's not enough to engage industry. We understand that. And worldwide, there is a move towards establishing demonstration factories or learning factories to help industry see the benefits of the next industrial revolution and collaborate to implement it. So, the benefits of these learning factories, they provide platforms for firms who are interested in the fourth industrial revolution to really commit to it. They're experimental platforms where concepts can be tested. They're collaborative product development spaces where solutions are developed in partnership. And they're also facilities for technical skills training and hands-on experience. And once again, like augmented reality, these facilities, if and when implemented in South Africa, can really help address that skills gap. In Germany, at last count, there were 14 such facilities, factories, learning factories, and there are many others around the world. So I conclude my presentation by sharing with you a concept that we are busy developing in CSIR to establish our own learning factory. It will be a partnership. We invite industry, we invite universities, we invite funding agencies to join us. And as we build this, we will be building the future. We see this as a critically important step in really in the marketing and the acceptance of the fourth industrial revolution to our industry. Thank you.